For section 1.2, we are going to be talking about using segment postulates to solve geometric problems. Some vocabulary that I want to introduce to you is the term postulate, which is just a rule that is accepted without proof. It's just things that don't need to be proven. In math, geometry goes through a lot of proofs, and you have to be able to explain exactly why something happens, and somebody's gone through the steps to do that, but there are certain things that are just accepted without proof. They basically just make sense more than needing to prove anything. We've also talked about distance formula. So the distance between 2 points, if you just have any 2 points written out anywhere, the distance between them is also just the length of the segment that connects them. So if I were to connect these two with a segment here, so the length from the distance from here to here is the same as the length of the segment that connects it. So if you ever see just the letters A and B without that picture above it, it's actually talking about the length of the segment in a numeric value versus the actual picture of it if you were to draw the segment on top of it. So if you ever see it without the segment, read this, the length of AB. So you're looking for a number answer here. Congruent segments. So the word congruent means equal. And congruent specifically is talking about the picture. So that two pictures are exactly the same shape and size. So if you see congruent, it's actually talking about a picture, but it just means equal lengths. And we talked about that in the first section, how you would see these tick marks if the lengths of the segments are congruent or equal. So the way that that's written out here is just an equal sign with a little squiggly mark over it if we're talking about the pictures. So the segment AB is congruent to segment CD. If we're talking lengths, we would say AB is equal to CD. All right, then the segment postulate that we're talking about today is called the segment addition postulate. So segment addition postulate, here's the book definition. It's talking about if you have a point between two other points on a segment, okay, so somewhere between them on this segment, then the length of AB plus the length of BC is equal to the length of AC, and vice versa. So this is called the converse of a statement when you flip the front and the back. So now they just flipped those around. So that's the book definition, but in my definition, or simpler terms for you thinking about this, maybe your definition would be something more like add the smaller pieces together to equal the whole segment. So we've just got these little chunks here, so we can just add this smaller red piece to the blue piece, and then we get the whole purple piece. So piece plus piece equals whole. No matter how many pieces there are, you could have a segment split into 15 pieces. They're all going to add up to the total as long as you get them all. So if you have a longer segment here and it was split up into multiple chunks, okay, if you just take all of these little pieces, so if you just had this piece, this piece, this piece, and this piece, just add all four of those pieces together and you'll get that whole. So that's going to be the idea that we're going to use throughout this lesson is piece plus piece equals whole, and the idea of congruent segments. So let's take a look here. So given the length of AB is 12, the length of BC is 3x minus 2, and the length of AC is 4x, first thing we want to do is always label the figure. So if there isn't a diagram drawn, you will want to draw one. If there is, you'll just want to label it. So the length of AB here, we're going to put 12. And then the length of BC, so from B to C, is 3x minus 2. Then they also give us the length of AC, so this whole thing right here. I wouldn't really draw it necessarily up here. I like to draw it below or just away from the rest of those and draw this little fancy bracket and put 4x here. If you maybe don't like trying to draw these, you could also just do something like this and just draw and put the 4x in the middle here just to kind of show that it's that whole piece. So then we're going to take and write and solve an equation. So this is where we really go ahead and use that piece plus piece equals whole idea. And I like to actually write out piece, like a blank, plus piece equals whole, and then just plug in the pieces. So we've got these two smaller pieces here. So 12 and 3x minus 2. Those are going to add together to equal the whole thing, and the whole thing is 4x. So whether you know the actual length or you have expressions for it, just plug it in. Now you're back to algebra 1, and you can just start simplifying. So on this side of the equation, we'll take and add together our like terms. So we have 12 and negative 2. So 12 plus negative 2 is 10. And then we have that 3x, and then equals 4x on the other side. If you like doing that, you can put the little line down the center here. Okay, then we want to take a look. We've got two terms here and only one over here. So which of these two, 10 or 3x, is a like term with the 4x? So it's the 3x. So we're going to want to bring this over to the other side. So this is a positive 3x. So we're going to subtract 3x from both sides, so that we're left with 10. 3x minus 3x is 0. 4x minus 3x is 1x. And we've solved for x. So our answer for x is 10. So I'm just going to write that over here, because the final thing that we needed to do after finding x was find the length of each segment. So now that we know that x equals 10, we can actually go ahead and plug it into these to find the actual length. So for AB, they just gave us AB, so we know that one's 12. For BC, we can go ahead and plug the 12 into the 10 into the x. So we'll go 3 times x minus 2, so plug 10 in there. So 3 times 10 is 30. Minus 2 is 28 for the length of that one. And then we want to go and find AC. So we'll do 4 times x being 10. 4 times 10 is 40. Now, I always do this little check because remember, it's supposed to be piece plus piece equals whole. So we should be able to add up the piece plus the piece, and it should equal that whole. So check, just do a quick check. Does 12 plus 28 equal 40? And it sure does, which is a pretty good indicator that you did the problem correctly. Next one, so draw a picture. I've already drawn it for you. B is between A and C. So we would just draw a segment with A and C being the end points, and then B being somewhere in between those two along this segment. I like to not draw it exactly in the middle, because unless they tell you that the two pieces are congruent, you don't know that. So if you draw it and you almost draw it exactly in the middle, sometimes you'll accidentally think the pieces are equal. So I like to draw it off center. Then they also gave us all of this information here, so we're going to go ahead and draw that on the picture. So AB is 2x minus 7. BC is 6x plus 12. And then AC is 45. So again, now we just want to go ahead and set up an equation to solve for x. Like I said, I like to do blank plus blank equals blank. So the pieces add up to the whole, and then just plug them in. So what are the pieces? Well, the pieces are these little chunks. So 2x minus 7 and 6x plus 12. And then the whole thing is 45. So now that's the geometry behind it, is just knowing that those two pieces add together to equal the whole thing. Now you're back into algebra 1. So now you're going to go ahead and combine your like terms. Okay, so we've got this 2x and 6x to get us 8x. Then we've got negative 7 and positive 12. So negative 7 plus 12 is positive 5. So then we get plus 5. and then equals 45. Now we have two terms on the left-hand side and only one on the right-hand side. So which of these two terms is a like term with 45? And it's the 5. So we're going to want to bring that one over. So we have a positive 5. So we're going to want to subtract 5 from both sides. So you're left with 8x. 5 minus 5 is 0. 45 minus 5 is 40. Now to solve for x, we have 8 times x equals 40. So we'll undo the multiplication with a division and divide by 8 to both sides. So then you get x equals 5. So once you get x equals 5, then it says find the length of each segment. You got to be careful because in Algebra 1, you would have been done with solving for x. So now a lot of times in geometry, it's going to ask you to actually go in and find the length of the segments. So don't forget that. So now that we know that x equals 5, we'll go into each of these and plug it in and solve. So 2 times 5 minus 7. 2 times 5 is 10. 10 minus 7 is 3. So we get 3 for AB. Then we'll go to the next one and plug in 5. So 6 times 5 plus 12. So we have 30 plus 12, which is 42. And then AC is the whole segment. They gave us that at 45 with nothing to plug in. Now, some of you might be confused when you look at this picture because it says that AB is 3 and it says that BC is 42. And on the picture, BC is way smaller. That's because I just randomly drew it. So you can't go by the picture, go by the math. Okay, and just check here. So check, does AB plus BC equal AC? So 3 plus 42. Does that equal 45? And it does. So we are likely right. So your picture doesn't have to be drawn to scale. It doesn't actually have to look the way that it should for it to work out. All right, final example here. We've got all of these figures down here and different lengths given to them. So given that AB, so find AB, is 7x minus 4. And EF is 4x minus 8. So here's EX, 4x minus 8. And then HG is 2x plus 4. Write an equation and solve for x, then find the length of each segment. Now this one is different because we don't have any segments chunked up. We don't have any segments just broken up. We've got multiple segments that aren't touching each other. So if we take a look and analyze these diagrams, we hopefully see something that we talked about in these tick marks, okay? So hopefully you see these tick marks on here. So we've got 1 tick mark here, 2 here, and 1 here. So each of these two segments has 1 tick mark. That means that they are equal to each other. So they are congruent segments, which means that they have equal length. So each of those pieces are going to equal each other. So we will say each of those segment lengths, 2x plus 4, is equal to 4x minus 8. That would be the equation. We can just ignore this one for now. Then go ahead and solve this. So now you've got like terms on both sides. So you can start with the x's if you want to, or you can start with the constants. I know some people don't like these negatives, so they like to start with that. So I'm going to do that. I'm going to take and add 8 to both sides. So now what I'll be left with on this left-hand side is I have 2x. 4 plus 8 is positive 12. And then equals 4x and then 0 here. So now I have x's on both sides. So now I'm down to 1 term here. So which of these two is like this one? And it's the 2x. So we're going to subtract 2x from both sides to bring that whole term over to the other side. Remember, don't start dividing until your x's are all together. So now we have 12 equals 2x. We want this x by itself, so it's 2 times x, so we're going to divide both sides by 2. And we will get 6 equals x. So we can go ahead and put that in here. Now we want the length of all three of these segments. So now you can just plug 6 into this whole problem, because even though we didn't use AB, x is still 6 in this entire problem. So we'll just go ahead and plug it into each of these. So for AB, we will have 7 times x minus 4, x being 6 now we found out. So this 7 times 6 is 42, minus 4 is 38. We'll go ahead and plug it into EF. So 4 times x minus 8, x being 6. So we get 24 minus 8, so we get 16. So now we know HG should be 16. So you could just write it down, but if you did something wrong in your algebra, then you'll find out by plugging it in. So if we do 2 times x plus 4, when we plug 6 in here, it should equal 16. If it doesn't, then we know we did something wrong. So 2 times 6 is 12 plus 4 is 16, so that's good. We found out that these are in fact the same like we said. Okay, so I do suggest plugging it in, making sure that they are equal so that you can catch any mistakes you may have made in your algebra.